let's start. So what are the primary mode of execution? Three modes of execution.
Client mode, uh, cluster mode, and local mode.
Okay. All right. So client mode, cluster mode, and local mode. Local means it runs on a single machine. Cluster means it's running on a cluster of machines, which is nothing but distributed network. And then driver client mode is
Driver program will run on a local machine and rest will run on the cluster machine.
exactly. And then in the cluster, we have standalone, Yarn, Kubernetes, and Mesos. Standalone means it is mainly used for testing purposes. Yarn means it is mainly it is yet another resource negotiator, which means it is built on top of Hadoop, and it is mainly used when we're working with exabytes and terabytes of data. Kubernetes is where it is mainly used to integrate with containerization or Docker containers, which is mainly used for orchestration. And Mesos is mainly used for
Carefully
monitoring.
observe the monitor the work.
Exactly, because of limitation on cost. Okay. Awesome. All right. There are two types of transformations. What are they?
Narrow and wide.
Narrow and wide.
Which causes shuffling, narrow or wide?
Wide.
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 Correct. Correct. Wide causes shuffling. All right. And uh, how does the stages gets created?
In DAG.
Wide is
In DAG.
Wide shuffling causes new stages.
Correct. Every time there is shuffling and there's exchange of data between nodes, it breaks into a new stage. Correct?
Yes, sir.
Awesome.
Yes.
Awesome. 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 Well done. All right. Today, we're going to talk about adaptive query execution. Now, what is this? AQE is an optimization technique, and we already know what optimization is. Optimization means making the code run faster and cheaper. All right. So we use optimization techniques to make sure the code is running faster and cheaper. Now, AQE and Catalyst Optimizer, they are built-in optimization techniques. So we are not doing it manually. It is done automatically. And what does it do? Let me explain. So Catalyst Optimizer does it by default. We don't have to activate anything or we don't need to trigger anything. It does it automatically. But what is Catalyst Optimizer? It is mainly designed to optimize your SQL queries. Okay. It is mainly designed to optimize your SQL queries. All right. And obviously your data frame operations. All right. Now, how does this work? Very, very simple. So first thing first, it is almost the same as SQL optimization techniques. Now, what are the different SQL optimization techniques? What is the first optimization techniques of SQL?
Use
column
the
instead of
indexing.
use column, sir.
Proper indexing.
Correct. In this case, we don't have indexing. All right. In PySpark, we don't have indexing because we're not creating tables. All right. But we have the other ones. Number one, you remember the abstract syntax tree, the Christmas tree that it creates, and it organizes your code on top of this syntax, in top of this AST. All right. And it will rearrange the code depending on which code is best to execute. All right. Which code to execute. All right. Then the next one is it creates, after this, it creates a logical plan on what not to do and what to do. And then it uses something called predicate push down. What do you mean by predicate push down? All right. Um, sorry. Okay. What do you mean by predicate push down? Do you remember why do we use where clause in SQL? What is the advantage of using where clause?
It filters
We
the
can
data.
filter the rows,
Correct.
Specifies what you want.
conditions.
Okay.
Selects only required data.
So, what it means is it will filter out unwanted data. That means you get filtered out data in your output. All right. You will get less data in your output when you use predicate push down. So in SQL, we call it where clause. In PySpark, we call it something called predicate push down, which means the data is filtered closer to the source. Got it? And hence we will get less data, which means it'll be cheaper and faster. Then we have column pruning. What do you mean by the word pruning? Pruning means what? Removing. Correct. Prune means remove. All right. So if I do column pruning, that means I am removing unwanted columns. Got it? I am removing unwanted columns. And again, in SQL, how do we do this? We do it by selecting the columns that we need, correct?
Yes, sir.
Yes.
Same thing again. So in this also, it will automatically prune on unwanted columns and it will only select whatever columns that we need. Then join reordering, which means it reorders the joins to make sure the query runs in the fastest way possible. Okay, so reordering joins is also one of the optimization techniques. And after doing all this, it will produce a final plan, which is a physical plan. All right. So first, it will create a syntax tree like in SQL. You remember explain, analyze, where we write explain, which will tell us how the code will get executed. And analyze means it will tell how long it will take and all that, the goods and the bads. All right. Then we create a logical plan. It creates a logical plan, which means it will tell what is good and what to do and what not to do in your code. And then it applies the filters. Then it removes the columns that we don't need. And then finally, it will reorder joins and creates a final plan. Got it?
Yes, sir.
All right. So this happens automatically. We don't do it. Catalyst optimizer is a built-in optimization techniques. So we don't handle this. Then we have AQE. What is AQE? AQE stands for Adaptive Query Execution. What do you mean by adaptive query execution? What does the word adapt mean? Adapt means what? When do you adapt to something?
Adjust.
Temporary something.
Adapt means adjust. Correct. So when I'm running the query, I am getting some information about how the query is running. Correct. During compile time, execution time, it is giving me information how the query is running. All right. So for example, let's say you have a car and you're driving the car. Depending on how you're driving the car, imagine the car starts optimizing. What do you mean by optimizing? It starts understanding, okay, this guy is driving very fast. So we should pump more fuel and we should also do XYZ. I'm not a mechanical guy, but you should do XYZ so that the car runs very smoothly and efficiently, but without your input. It is doing it automatically. All right. And this adaptive query execution is while running the query, it will understand based on the feedback it is getting. it is understanding, and it is executing appropriately. Got it? Then we have partition pruning. Partition pruning means we have unwanted partitions. Let's say I hired 10 chefs, correct, to execute 100 dosas. All right. After some time, after executing 100 dosas, all right, we only got 10 dosa order or 20 dosa order. Now, how many chefs are sitting quietly there?
8.
8 chefs are sitting quietly. Now, do I need to pay these guys and make them sit quietly? I mean, if I have too much money, yes, I can. But if I have, if I'm working on like strict budget, what should I do? Should I like get rid of the remaining 8 chefs and only call them when I need them? Yes or no?
Yes, sir.
Yes, sir. Yes.
So that is partition pruning. So if I've created 10 partitions, now for the next job, I don't need 10 partitions, or maybe for the same job, suddenly we filtered out data. After filtering data, after column pruning and all that, the number of partitions needed is less. So in that scenario, what do? We remove the unwanted partitions, correct?
Yes, sir.
Yes, sir.
Okay. So that way, we are removing unwanted partitions, which means it will also automatically do this while executing the code. Whatever partitions we don't need, it will remove it. Then we have skew handling. Okay, first of all, we need to understand what data skewness is. Okay. Let's say I have 100. Does everybody know what fact table and dimension table is?
Yes, sir.
Yes,
Yes,
sir.
sir. Fact
Yes, sir.
table is one.
Fact
Yeah.
table is
Fact
what
table.
data dimension
Fact
is the
table
description
is
of the
facts
fact
in the
table.
data block,
Description of the
and
data.
the dimension tables it describes whatever.
Correct. But batch 47 guys, you guys know what fact and dimension is?
So little bit of idea. I've read that PDF.
Okay, no worries. Okay, let me explain what fact and dimension. Guys, if you don't understand, just stop me, guys. Batch 47, please. I want everybody to sail on the same boat. Don't be shy, okay? Just ask me whatever you want, okay? All right. Now, fact table is numerical data. Okay. Any numeric. So we'll have two types of tables, correct? We have does everyone know the batch 47 guys? Do you guys know relational tables?
Yes, sir. Relations based on keys.
Primary key, foreign key relationship, correct?
Yes, sir.
All right. So let's say we have customer table and we have orders table. In the orders table, we have information about the orders that has been placed. And customer table has information about the customer. So to get which customer placed which order, what do? We join those two tables, correct?
Yes,
Yes.
sir.
Okay.
Correct.
So in the orders table, we have factual data, which is nothing but your information about your orders, which is numerical data. Okay, any numerical data will be in your fact table. Okay, which is total amount spent and all those kind of things. Got it? So anything that defines this fact becomes your dimension. For example, in orders table, let's say total amount spent is 5,000. Now, what are the questions you will ask? Who spent this 5,000? That means that is coming from my customer table. What was it spent on? It means it's coming from my product table. When was it delivered? It's coming from my logistics table. Correct. All this information that defines your factual data becomes your dimension data. Got it? Or your dimension table. You guys understood?
Yes, sir.
Yes, sir.
Yes.
Okay. Now, let's say in fact table, orders table, there was this one customer. Let's say my wife. Let's take my wife. Okay. She's ordering too much every day. She's ordering at least 5-6 items on Amazon. Okay. Now, other customers are ordering only 1 or 2 per week, but she is ordering every day. She's ordering 5-6 items. Okay. So when I distribute the data, when I partition that data, okay, let's say I am partitioning it based on range. Range means from ID number 1 to ID number 1000, go to here. From 1000 to 2000, go here. 2000 to 3000, go here. 3000 to 4000, go here. 4000 to 5000, go here. So we are dividing based on range. Okay. Now let's say if I divide this data like this, okay. So customer ID 1, all right. Let's say my wife's ID is 1, okay. And she has, let's say, out of 100 orders, 50 orders is hers only. So that means this partition will have more data. Yes or no?
Yes, sir.
Yes, sir.
Correct. And the remaining will have less data. Maybe this will have 10, 10, 10, 15 or something like that. But because we did it based on range, on ID, all right, the ID of the customer, that means this will have all ones. All right, which means almost 50 of it is only my wife's. Okay. So that means when I start executing this or start running my transformations, will this take more time to run compared to this?
Yes.
Yes.
Okay. So this will take more time to run, which means I have to go one partition is taking longer than the other partitions. Comparatively, it is taking more time to execute compared to other partitions. Okay. This was an interview question today. Okay. How do you handle data skewness? So this partition is taking too long compared to the other partitions. So what will happen then? So then I have to make sure that I have to divide this equally amongst this somehow. All right. Somehow I have to make sure that that data gets equally divided amongst all these. So for that, we use first, what we'll do is we will take this data and we will say, can you redistribute the data? So we will do repartition, which means the data will get redistributed again. Okay. And I'll see if it is fixed the problem. If it is not fixed the problem, which is very unlikely in this scenario when there is data skewness. Data skewness means whatever I told you. One partition is getting more data than compared to other partitions. So the distribution of data is not equal. So it is taking longer to execute this compared to the other ones. Okay. So when I run this execution of this of this code, then what will happen is this is taking longer. So what I'll do is I will say, can you repartition again, and we'll see if it fixes the problem. So we will repartition it. Even after that, if it does not get fixed, what do? I'll have to do something else. So that something else is called salting. Salting as in the salt, pepper salt, SALTING, salting. Now, what is this salting? Very simple. What I do is, let me show you an example. Okay, so I have ID like this. Okay, and in this ID, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But because of data skewness, one second. Okay. Because of data skewness, let's say this is something like this. Oi, 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 my. Okay. 2, 3, 5, 6, 8, something like this. Okay. So 50% is almost my ID number 1. So what I do is I add something called a salt key to my data frame. Okay. And what I'll do is I'll do some sort of mathematical calculation. Usually it is going to be like a random mathematical calculation. All right. So I will add some sort of a suffix to this, or I will do some mathematical calculation. And for example, I'll do equals that. Why is this not working? That divided or percentage 10. So there is no modulus in this. That is why it is throwing that error. Anyways, I'll take the modulus, or I will do 1 underscore and I will add some random number there. So what I'll do is, okay, let me say rand between 1 comma 10. Okay. Then what I'll do is here equals that plus scroll key plus this. Sorry, my keyboard is playing now. I think it is ampersand.
Or use concurrent.
Oh, so I added a random key like this. Okay. So this is giving me a random number, and this is this is giving me a random number now. Now, if I distribute the data based on this column, will it be more evenly distributed or randomly distributed?
Yes.
Yes, sir.
Yes, because it has changed the uh, the ID which I am going to distribute it based on. All right. So I have just added a random number here between 1 and 10, and then I'm just adding that. Okay. So now what is happening? It is just distributing based on this random key here. And because it is distributing based on random key, the data will be more evenly distributed across all the nodes. Got it? Yeah. So this is called your salt key. Okay. I'm just showing a random calculation, but in your real world, it can be some sort of concatenation or something we can do. All right. To create this salt key, which means after, if I distribute it based on this salt key, I will the data will get distributed more evenly across all the nodes. You got it? Yes?
Yes, sir.
Yes, sir.
All right. So once I finish distributing the data across all the nodes, I don't need this salt key. So what will I do? I will delete this salt key. That's all. Got it?
Yes.
I don't
Yes,
need
sir.
this. So once the data is finished distributing to this more evenly, then I will distribute that salt key. Got it?
Yes, sir.
Understood? Anybody who has doubt on salting, what salting is? See, salting is a process where we are doing something to more evenly distribute the data across all the nodes. All right, first we will try to redistribute it before adding the salt key. If that did not fix the problem, then I will add the salt key based on a random calculation. Got it? And after adding this random calculation, the salt key, I will redistribute it again across all the nodes. So that way, the data gets distributed evenly across all the nodes, and hence it will distribute it more evenly because it is distributing randomly across the nodes. And then finally, I will delete that salt key because I don't need that salt key. The data has been distributed evenly now. So I don't need that salt key anymore. Got it?
Yes, sir.
Yes, sir.
Any doubts? It is an interview question. If you have doubts, ask me, darlings.
So basically, sorting means like to spread the data randomly, like we are using some method, right?
We're just adding a mathematical number to your ID. So that way, see here, if I distribute this, then all the ones will go to one partition. Then maybe two will go to one partition, and 2, 3, 4 will go to one partition. Then 5, 6, 8 will go to another partition. All right. So we don't want that. We want it to be randomly distributed and evenly distributed, as evenly as possible. So because of that, what we do is we add a salt key, which is like a dummy key, which makes that ID a more random number. All right. And once we get that random number, then I can guarantee that, see, all the ones will not go. You see, maybe all this will go to one partition, all these will go to another partition, all these will go to another partition. So it is distributing more evenly now. You understood?
Yes, sir. So I have one more doubt regarding like data queueness. So it is basically the same kind of data or like same amount of the data.
So it
Like
is, see, if it is not same kind of data, it is like one customer's data or one type of data, all data is grouped together and it is causing delay in execution because there's too much data in that partition. You understood?
I'm asking that only. It's like it is the similar amount of the data or like maximum amount of the data in one partition that is causing that problem.
Correct. Too much data in that partition.
Okay, sir.
Okay.
It
So
has nothing to do with the like similarity, right?
it can, you see, too much data can be caused because of similarity as well. No, like here, all these are similar data, like not similar as in similar ID, same ID. So all these are going into the same partition, and it because of that, it is having too much data compared to what it should have, what the other partition has. So because of that, it is causing delays.
Okay, sir.
Okay,
Okay, sir.
awesome. See, when you do partition, it has to be as evenly distributed as possible. All right, it does automatically, yes, but you're distributing based on certain criteria. And I'll tell you what the two types of partitions are. You remember we did range partitioning and hash partitioning? in SQL? No? Okay, we'll do it again. Hold on. Okay, so when we distribute the data gets distributed based on two types of partitioning. One is called range. All right, there are different partition types. One is called horizontal, then vertical, then range, then hash. All right, all these are different partition types. Okay, now with these partition types, we have this is how the data gets partitioned. By default, it uses hash partitioning, which I'll tell you what hash partitioning is. Okay, so first, horizontal partitioning. What is horizontal partitioning? All right, it divides the data horizontally. All right, it divides the table into multiple tables. One second, guys. Hello? Yes? Okay. Horizontal partitioning means it divides the table into multiple tables, and each partition will have the same some part of that table, and each table will have the same number of columns. So horizontal partitioning means it is dividing horizontally like this. Okay, you see, this will be one partition, this will be another partition, this will be another partition. Let's say here. Okay. Now, does each partition have the same number of columns?
No.
No.
It will have, darling.
Yes.
Yes.
So when let's say when I partition it based on horizontally, which means don't you think this entire thing will go into one partition? Then this entire thing will go to the second partition. Then this will go to the third partition, and this will go to the fourth partition. So the number of columns will be the same. Number of rows will be different. Yes or no?
Yes, sir.
Yes, yes.
Yes, sir.
So this
Yes,
is
sir.
horizontal partitioning. Vertical partitioning means it will divide like this. Maybe every 3 columns or 2 columns, it will divide like this. Now in this, the number of rows will be same, but number of columns will be different. Correct?
Yes.
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 Yes, you understood?
Yes, sir.
So number of rows will be different. Number of rows will be same, but number of columns will be different. That is vertical partitioning. Horizontal partitioning means number of columns will be same, but number of rows will be different. Okay. Then we have range partitioning. Range partitioning means each partition is based on a specific range. All right. Let's say I defined the range as 1,000 rows per partition. All right. Which means each partition will have approximately 1,000 rows of data. Got it? And then finally, we have hash partitioning. Hash partitioning is done by default. Now, what is hash partitioning? Let me show you. Okay. Again, hash partitioning, it uses a random algorithm. All right. So we'll have 1, 2, 3, 4, 5. All right. 1 second. Okay, I have a new employee in my office and he's messing the place up. Do you want to see my new employee?
Yes, sir. Yeah.
Let me show you. He is going to be my social media. Can you see?
Yes, sir.
Hey, wow, is so cute. Yeah.
वो पैर उल्टा डाल दो बस पानी है ना नहीं वाइट कलर
पानी नहीं नीचे तो करा लगा हाँ
okay so yeah he's been messing the place up today is his first day that's why anyways so I have let's say data like this okay 1 2 3 4 5 all right and then I have 6 7 8 9 10 or let me do it like this okay it'll be easier to understand 101 102 103 104 105 106 107 108 something like this okay so we have IDs like this so how will this partition be defined so let's say this percentage 10 is what oh you know what I mean so if I do modulus of this what will be the modulus of this so if I do 101 modulus 10
1,
this is 1
1
this will be
2,
2 3 4 5 6 7 8 correct then 109 then 110 111 112 so now when I do modulus of this will be 9 this will be
0, nothing.
0 this will be
0,
1,
1,
this will be 2
2.
so all the ones will go to partition number 1 all the twos will go to partition number 2 all the threes will go to partition number 3 so like this is called hash partitioning the partition will be based on some mathematical calculation got it
yes, sir.
And it's not always modulus, right?
it is not
mathematics.
modulus this is an example that I gave you so we don't need to know what calculation it is using it is just an example I gave you that it will be divided based on some mathematical calculation which we don't need to know by for example I gave you that modulus one okay
So is it similar to sorting, sir?
what ma
Is it similar to sorting? Like there also you have done the same thing, like by using the
no
sort.
no this is partitioning okay this is partitioning so if I let's say if I have ID number 101 who did most of the transactions. Okay. Then what will be the modulus here? 1, 1, 1, 1, 1, 1. Now, don't you think all these guys will go to the same partition?
Yes, sir.
So this is hash partitioning is how it partitions. Okay. Sorting is a solution for this problem when there is data skewness. Correct. This is not solving the problem. Correct. Even now, ID number 101 is all going into the same partition. Yes or no?
Yes, sir.
Okay. It is a partition technique. It is hash partitioning. Sorting is where I am adding a random number to this so that I can solve that partition technique, partitioning problem. Got it?
Yes.
Yes, sir. Got it.
Yes, sir.
So now I'll do this is equal to that plus this. Now this will become a random key. Correct? So now, even if by default, all this was going to random partition 1. Now is this going to partition 1? If I distribute based on this?
No.
No.
No, this will go to 9, this will go to 5, this will go to 9, this will go to 2, this will go to 10. So is it not more evenly distributed and randomly distributed?
Yes.
Yes, sir.
You understood the difference between hash partitioning and data
Yes, sir.
sorting?
Yes, sir.
Yes, sir.
So hash partitioning is how it partitions. Sorting is a solution for that if there is data skewness. Got it?
Yes, sir.
Yes, sir.
All right. So now what are the 4 partitioning techniques? We have horizontal, vertical, range, and hash. By default, Spark uses hash. Okay. This is how it partitions the data. You guys understood?
Yes.
Yes, sir.
Yes.
Any doubts in this? Even silly doubt, ask me, guys.
No, sir.
No? Should I move forward?
Yes, sir.
Yes, sir.
Okay, okay, okay. All right. I've already explained data skewness, so we don't need to go through this. All right. So we use salt technique, and then we create a new column and we distribute based on that. And then we delete those columns. Okay. Then I have other optimization techniques. One of them is called repartition. All right. What is repartition? I think I already told you what repartition is. Repartition means redistribute the data again. Correct? Okay.
Yes.
So I'm redistributing the data. Now, what does repartition do? We can use repartition to increase the number of partitions or to decrease the number of partitions. So I can increase the number of partitions or decrease the number of partitions. Both can be done using repartition. So let's say I have, how many are these? 1, 2, okay, let's say, okay, I have 1, 2, 3, 4, 5, 5 partitions. All right, now let's say I want to increase the number of partitions to increase the parallelism. So I will use repartition and I will put 7. Okay, so it will increase the number of partitions, all right, to 7. And what it will do is, it not only increases the number of partitions, but it will redistribute the data again. You understood?
Yes, sir.
So when I increase the number of partitions, it will increase, it will add 2 more partitions, but it will redistribute the data again. Okay, so that is repartition. But there is a problem with this. The problem is it causes shuffling. Got it? It causes shuffling, and shuffling is not
Good thing.
good, not a good thing. But we don't have any other way to increase the number of partitions without shuffling. So to increase the number of partitions, we have to use repartition. All right. But we also have something called Coalesce. Coalesce. All right. A lot of people pronounce it Coalesce, but it is the actual way is Coalesce. All right. Coalesce is used to reduce the number of partitions, and it cannot increase the number of partitions. It can only reduce. Got it? So if it can only reduce the number of partitions, all right, then why am I using Coalesce instead of repartition? I can use repartition only, right? Because repartition does both. Coalesce only does reduce. Then why should I use repartition? All right. The reason is Coalesce does not do shuffling. Repartition does shuffling, but Coalesce will not reshuffle the data. You understood? So to reduce the number of partitions, which is better for me to use?
Coalesce.
Police.
Correct. And to increase the number of partitions, I have to use repartition because I don't have any other choice. Got it?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Awesome. Well done. So they will ask you what is the difference between repartition and Coalesce. So the way you should answer this is, so repartition is primarily used to increase the number of partitions, and Coalesce is used to reduce the number of partitions. We use Coalesce to reduce the number of partitions predominantly because it does not do a full shuffle. But repartition will do a full shuffle of data. So we don't use repartition for reducing the number of partitions, although it can do it. We don't use it. We use Coalesce to reduce the number of partitions. You understood?
Yes.
Yes, sir.
One doubt.
Yes, ma'am.
So what happens when you reduce the partition? Then what happens to the data?
So whatever the
Different
data is there in those parts, see, let's say I'm reducing the number of partitions. There's maybe about 30, 40 records. Those records will get moved to another partition automatically. Okay, but it will not do a full shuffle. It will not redistribute the entire data for all partitions. Whatever is inside it, it will just go to another partition. Got it?
Okay, sir, got it.
Awesome. All right. Now they asked one more question today. Okay. This was Altimetrics final round. Okay. They asked one more question. They asked, okay, let's say I have 20 partitions. All right. In that 20 partitions, actually, this interview was really good today. One of my very favorite interviews. Why? Because he asked very good questions, very, intelligent questions. Got it? So he asked, if I have 20 partitions, all right, and I want to remove partition number 16 to 20. Okay, I want to delete these partitions. Can I do it? Now, answer to that is you cannot. So Spark will not, it will not give you an option where a number is given to each partition. Okay, it is a partition, but there's no number given to each partition. So you cannot select specific partitions and delete it. Got it? The way you should reduce it is by using Coalesce. Got it? You cannot delete internal partitions. Right? You can use Coalesce to reduce the number of partitions, but you cannot delete them. Like selecting partition 1, partition 2 and all that, you cannot delete them. Got it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Also, do you guys know what factless fact table is? So we know what fact table is, numerical data, correct? Which is factual data, like now total number of orders, total number of total amount of expense, whatever. But what is factless fact table? So factless fact table means there is no factual information, but there is like normal numerical data like, ID column, date column, all right? So simple information, but there is no foreign key column, all right? Those kind of columns, still numerical, but it is not factual. You understood what the difference between factual data and non-factual data is? Factual data means it is quantifiable. You can measure it, like total number of shoes the customer bought, total amount of sales it happened. This is fact data. But ID is not fact. No, it is just a numerical data. You understood?
Yes, sir.
Yes, sir.
So if you have a table, but it does not have fact data inside it, then it becomes a factless fact table. You understood?
Yes, sir.
And where do we use this? Mainly if you have foreign keys. So we use it for relationship building. Or if you just want to keep a count of something, like, how many times did this happen? Like how many times did the name Chris show up in something? Something very simple, non-factual data. We use factless fact table for that. Okay, this was the first interview in the last 15,000 interviews I attended. First interview, they asked this question. Very smart. And even that other question, they've never asked that question. All right. But this was the first time they asked it, and I loved it. Okay. because these are all intelligent questions. Usually what they do is they ask the same, if you get my, what do you call, this, no, what do you call, my golden question paper, no? All the questions will be from there only. All right. So it will not be like I was getting bored. They're asking the same questions all the time. But this was the first time this guy was asking very smart questions. All right. Awesome. Okay. Then he asked, let me ask you some more questions that he asked. I won't ask AWS because we've not done AWS. He asked about AQE. All right. What is data skewness? How do you solve the problem of data skewness? What is AQE? How does AQ do things? Okay. This also comes in AWS, no problem. Okay. He asked one more question. Okay. Let's say we have data skewness in our data. Okay. The data is already skewed. Now, if I add one more executor or partition to this, all right, will it solve the problem?
No, sir.
That's all. That's the answer. All right. He asked this question. So if he said, let's say we have 5 executors. Executors is where workers, and suddenly we are adding 2 more executors. Will it solve the problem of data skewness? No, it does not, because the data is still skewed. So we'll have to use sorting techniques for that. Got it?
Yes, sir.
All right. Then he asked one more question. It was very interesting interview, and we answered all the questions. I think the guy was doing it well. Okay. 47. You guys did SQL, na?
Yes, sir.
Yes, sir.
Now, did you learn window functions?
Yes, sir. A little bit about it.
Yes.
Yes.
Do you know?
Yes.
Do you know how to use window function to get third highest?
We use rank.
Sir, using Dane's rank.
Dense.
Dense rank.
Dense rank. Okay. So he asked, I have, let's say I have a data frame, all right, or let's say I have a table, all right, in SQL, and we've not done SAD types yet, but I'll explain this. Okay. So let's say Krish calls up, and Krish's data customer table is there. All right. Krish calls up and he says, I want to change my phone number. And we change the phone number, but we use something called SCD, slowly changing dimension type 2. All right. What does that mean? We will not change the phone number wherever it is. We will add it in a new row. And I will say, this is the new data. I will not delete the old data, but I will just add a new row and I will tell this is my new data. Got it? So this is how we can add new data. Now he said, if I have done three changes, all right, to the same customer, but I want to find out the second change. How do we do it? It is something that we've done. It is not, let me tell you, it is not dense rank. It is something else. Can you tell me how? Think about it. We should.
Lag.
Sir, using lag.
we should do something. What should we do? We should divide it by something, partition it by something, and then apply one window function to it.
Row number.
Correct. So what we do is we break it down by the customer ID. So all customer IDs will be grouped together. Then we will do a descending order on the date. Correct. That way we will get which date the data was changed, and we will apply 1, 2, 3 row number to it. Okay. So when we do that, it will, then I can do where row number is equal to 2. Correct.
Yes, sir.
Yes.
Yes, sir.
Correct.
Sir, please show it in Excel file. Can't got it, sir.
Yes, sir. Question. You didn't understand the question.
Okay. So let's say I have 1, 2, 3, 4, 5, 6, 7. Okay, let me just say like this. All right. Then I do A, B, C, D, E, F, G. All right. Then let's say customer number 1 calls up and he says, my name changed from A to X. So now I'll do A1 and X. Okay. Now there's dates here. Okay. Update. When was it updated? So this is updated date is, let's say 2910 2025. All right. Then maybe this was done on 1st of January 2025. All right. All this was done on 1st of January 2025. Okay. Now let's say he calls up again and he says my name changed from X to Y, and this is dated on 30th 10 2025. Then ID number 3 calls up and he says I changed my name from C to G, and he did this on 29 10 2025. Okay. Now he said I want to know the second change of my customer. Okay. ID, name, date. Now how to find the second change for the customer?
Okay. Rank ID.
So
Rank
first,
over partition by ID.
Grouping by date and then giving the row number.
First I'll do grouping by date,
Yeah.
ID. So I will insert this. Okay. So I'm partitioning it by ID. Correct?
Yes, sir.
All right. I partition by ID like this. Then I'm applying row number. What does row number do? It will apply a unique row number. 1, 2.
Yeah.
Correct?
Yeah. But order by date descending.
And order by date descending. Correct?
Understood.
You understood?
Yes, sir.
So now can I do row number is equal to 2? Will it give me my second change?
Yes.
Yes.
Yes, sir.
Yes, sir.
You understood, guys, everybody?
Yeah.
Yes, sir.
Yes,
Sir,
sir.
like this, sir.
Huh?
I send one query, sir.
What, ma?
I send one query, sir.
What did you say? You send me one query.
He sent a
I
query.
I have sent one query, sir.
Okay. Select salary over order.
Oh, sorry, we used to tense, but we used row number here.
We are not using dense rank here. All right. Why
Yes, sir.
not?
Row number.
We should use row number.
Yes.
Got it?
Got it.
That way I can get the second change made by the customer. It is the same thing, but the logic is different. You understood?
Yes.
Okay. So this is how this works. You got it? Awesome. I'll discuss more questions in the next class. It is one of my most favorite interviews today. It was very, very nice interview. Okay. So you guys understood how this works, guys? All clear? So
Yes, sir.
Yes, sir.
you know what repartition is, you know what Coalesce is, you know what AQE is, you know what catalyst optimizer is, you know what data skewness is, and how to solve that problem as well. Yes?
Yes, sir.
Yes, sir.
Yes.
Awesome, darlings. All right. We'll continue from cache and persist in the next class. We're almost done with theoretical, okay? So there's not much theoretical to PySpark. The coding part is very easy. It is like same as pandas. All right. So we will do this. We'll finish off the theoretical in the next class, and we'll go to coding. Yes. Bye bye. Bye bye.
Sir, what should be the query of this?
Which one, ma?
Sir, last
Which one? This one.
yes, sir. Yes, sir. Yes, sir.
You do it, no? You do it and let me know in the next class.
Okay.
I've already done this in the class many times.
Okay, sir.
You do it and let me know. Correct, guys? Have I not done this?
Done.
Yes, sir. You have.
Yes, sir. You have done.
Same logic, but we're just using a different window function. That's all. Correct? So you will have to use CTE and get that second change that they've made. All right.
Okay, sir.
Awesome. All right, guys. That's about it. Thank you so much. And I'll see you in the next class.
Good night, sir.
Thank you, sir.
Thank you, sir. Good night.
Good night. Good night.
Thank you, sir.
Good night.